In 2000, the world's leading mathematicians gathered in Paris to identify 7 of the most important unsolved problems in their field. The nonprofit Clay Mathematics Institute organized the meeting and pledged $1 million to the first person to solve any of the 7 Millennium problems. So far, only one has been solved. In 1904, French mathematician Henri Poincaré posed this problem about the nature of space. He suggested that if you have a 3-dimensional space with no holes, it can be made into a sphere without ripping or cutting it. For example, a blob could be formed into a sphere. But it gets more interesting than that. To a topologist, a ball and a pillow are the same because they can be reshaped into one another. Similarly, a bagel and a mug are the same because they both have one hole, making them topologically equivalent even though they're not spheres. Poincaré suggested that anything without holes is equivalent to a sphere, so long as the object is small enough. It can't extend infinitely in any direction. He believed his conjecture to be true, but couldn't prove it. His conjecture was generalized to any number of dimensions, including 4 dimensions, which was particularly challenging to solve. That left the 3-dimensional case, Poincaré's original conjecture, which frustrated mathematicians for a century, until 2002, when a mysterious paper floated on the internet. Within this paper was a solution to the Poincaré conjecture. The author was Russian mathematician Grigory Perelman, known as Grisha. Grisha grew up in the Soviet Union and attended an elite high school in St. Petersburg specializing in math. Unlike the other exceptional kids in class, he was never distracted. He just sat and listened. He even refused to eat his lunch. As his teacher, Valerie Ritzik, told author Masha Jessen in her book on Grisha, maybe his entire nervous system was so tuned to the learning process that he could not stray from it. At 16, he won a gold medal at the International Mathematical Olympiad with a perfect score. Being part of the Soviet Olympiad team meant he could be admitted to Leningrad State University without having to take the entrance exams. The university was notoriously discriminatory, admitting only 2 Jewish students a year. But Grisha's place on the team allowed him to bypass this quota. After completing his studies, he did graduate work at the renowned Steklov Mathematical Institute's St. Petersburg branch, unheard of for a Jew. Grisha was accepted because influential figures like mathematician Alexander Alexandrov campaigned on his behalf and offered to supervise him. When Grisha began his grad work in 1987, the Iron Curtain was starting to lift, allowing Soviet citizens to travel abroad for the first time in decades. The renowned mathematician Mikhail Gromov arranged for Grisha to give talks in the US on geometry, his area of expertise. Gromov mentioned Grisha to the right people, ensuring he was invited to do postdoctoral work at NYU's Koran Institute of Mathematical Sciences and Stony Brook University. Besides math, his other passion was walking from Manhattan all the way to South Brooklyn to get his special black bread from a Russian shop. He later moved to the West Coast to take up a prestigious fellowship at UC Berkeley. Once his fellowship came to an end, top American universities tried to poach him. Princeton's top brass were so impressed by his guest lecture, they approached him about becoming an assistant professor and asked for his CV. Grisha reportedly responded, "Why would you need any more information?" Masha Jessen's book describes how Grisha didn't want to settle for anything less than a tenured position, whereas the university wanted the 29-year-old to earn his way there. When Tel Aviv University, where Grisha's sister was studying mathematics, offered him a full professorship, he rejected that too. He explained he could work better back in his homeland and returned to Russia to the Steklov Institute. What he was working on, nobody knew. Grisha was quietly tackling one of the toughest problems in math. How did he prove Poincaré's conjecture? Well, he managed to prove another conjecture, which indirectly proved Poincaré's. In the late 70s, American mathematician William Thurston suggested that any 3D shape can be decomposed into 8 different geometric structures. And one of these 8 shapes is the 3-dimensional sphere, which is central to Poincaré's conjecture. Thurston never managed to prove his own theory, but American mathematician Richard Hamilton gave it a go, trying to tackle both Poincaré and Thurston's conjectures. He couldn't prove them, but he did develop the blueprint that helped Grisha finally crack the century-old mystery. Grisha relied on Hamilton's powerful mathematical tool called Ricci flow to study shapes. Think of Ricci flow like heat spreading through an object, smoothing out bumps and irregularities over time. As Ricci flow progresses, certain regions can become very thin, forming necks. Grisha used a process called surgery to cut off these necks to study the pieces separately. He realized that these pieces ultimately represented the simple shapes that correspond to the structures predicted by Thurston's conjecture. So by solving Thurston's conjecture, he in turn proved Poincaré's. Grisha published 3 papers totaling 992 pages. When he uploaded the first to arciv.org, a public forum operated by Cornell University, he emailed about a dozen American mathematicians to give them the heads up. This was totally out of the blue. He hadn't spoken to his colleagues for years and barely responded to their emails. Mathematicians spent over 3 years scrutinizing his proof to see if he had really solved the problem. But Richard Hamilton was not one of them. Grisha was apparently hurt that Hamilton, whose foundational work he relied on for his proof, showed little interest in his achievement. Grisha told The New Yorker, "I had the impression he read only the first part of my paper." Why was Hamilton so apparently disinterested? As author Masha Jessen put it, it took Perelman less than half of his first paper to get past the point at which Hamilton had been stuck for 2 decades. No wonder Hamilton was silent. One can only imagine what it must have felt like to see one's life ambition hijacked and then fulfilled by some upstart with unkempt hair and long fingernails. Mathematicians who showed more enthusiasm finally had the chance to speak with Grisha in person when he was invited to lecture at several American universities. By 2006, it became clear that he had indeed solved Poincaré's conjecture. In a confusing twist, 2 Chinese mathematicians, Cao Huaidong and Zhu Xiping, claimed they had proved the Poincaré conjecture, calling it a crowning achievement. But the crown belonged only to Grisha. Yet, he declined the $1 million prize. Money never motivated him. He told a Russian newspaper, "I know how to control the universe, so tell me, why should I run for $1 million?"
A Fields Medal is awarded to Grigory Perelman from St. Petersburg.
Grisha was also awarded the highest honor in math, the equivalent of the Nobel Prize, but he didn't show up to the awards ceremony in Madrid.
I regret that Dr. Perelman has declined to accept the medal.
Grisha explained to The Telegraph that he wasn't interested in the attention. "I do not think anything that I say can be of the slightest public interest. I know that self-promotion happens a lot, and if people want to do that, good luck to them. But I do not regard it as a positive thing. Newspapers should be more discerning over who they write about. They should have more taste." This was one of the rare interviews he did. He wasn't a fan of journalists prodding, and once, when a reporter managed to reach him on his phone, he responded, "You are disturbing me. I am picking mushrooms." Despite offers to teach at MIT, Princeton, and Columbia, he turned them all down. The mathematician and investor Jim Simons, who had elevated Stony Brook's math department to top-tier status, reportedly offered Grisha any salary and any terms he desired. But Grisha refused and returned to Russia in the spring of 2004. He resumed working for the Steklov Institute and was promoted to lead researcher, receiving a salary of around $400 a month. Once, when he got paid nearly double his monthly salary because his lab had leftover grant money after completing a project, he insisted the extra money be returned to the Institute's accounting office. Grisha lived his life by his own set of principles. And then, in December 2005, he left the Steklov Institute. As recounted by author Jessen, Grisha reportedly told the Institute's director, "I have nothing against the people here, but I have no friends, and anyway, I have been disappointed in mathematics, and I want to try something else. I quit." Not only did he withdraw from the mathematical world, but from society as a whole. Very little is known about what he got up to afterward, except that he lived with his mom. A picture of what appears to be Grisha looking disheveled and far removed from the accolades he chose not to receive circulated online recently. As for what happened to the $1 million he refused to accept, the Clay Institute used Grisha's prize money to fund the Poincaré Chair, a temporary position for young promising mathematicians at the Henri Poincaré Institute in Paris. Grisha's story is both inspiring and thought-provoking, highlighting the incredible heights of human intellect and the personal choices that define our lives. If you've been inspired by his achievements and want to improve your own skills in math, you'll love learning with Brilliant. Geometry was fundamental to Grisha's work, and you can get hands-on with these concepts in Brilliant's measurement course. You'll learn to recognize relationships between shapes to find angle measures, side lengths, and areas without calculations. I personally use Brilliant for 10 minutes a day to explore the How LLMs Work course. It's one of my favorites because it offers a great way to get hands-on with how real language models generate text that sounds human. There's something for everyone, no matter your skill level. Whether you're a beginner wanting to learn how to program, or you'd like to brush up on what you already know, Brilliant has something for you, and you can start learning for free. By signing up at brilliant.org/newsthink, you'll get to try Brilliant for free for 30 days. That's brilliant.org/newsthink, link in the description, or scan my custom QR code on your screen. If you sign up with my link or code, you'll also get 20% off Brilliant's annual premium subscription, giving you access to thousands of lessons. Thanks for watching. For Newsthink, I'm Cindy Palm.